Today we will discuss about evolution of stable state currents and voltages in the bistable multivibrator. Okay. First of all, see the bistable multivibrator circuit. This is the mild two cross coupled transistors. Okay, that means one transistor output is connected to the input of the second transistor. Okay, here let us assume this is the current I1. I1 can be divided into I1 can be this at this point. I1 can be split into IC1 plus I1 dash. Okay, na? So from VCC to I1, there it can be divided into IC1 and I1 dash. Similarly, current I2 can be divided into I2 dash plus IC2. Okay, again this I1 dash can be divided into I1 dash is divided into here. This is the base of the transistor Q2. This is Q2. This is Q1. Okay, I1 dash is divided into base of the transistor 2. So this is IB2 and I4. Okay, I1 dash is divided into IB2 and I4. Similarly, I2 dash is divided into it is connected to the base of the transistor Q1 as well as minus VBB. Okay, then I2 dash equal to IB1 plus I3. Okay, this I2 dash is divided into IB1 plus I3. Okay, so let us first draw this circuit and mention all the current and voltage values in the circuit. Okay, first let us assume that Q2 is on and Q1 is off. Okay, you can select Q1 on, Q2 off. Okay, in this case I selected that. I assume that Q2 is on and Q1 is off condition. Q2 is on means output of the Q2 is in saturation, that is at this point VD, the collector voltage, output voltage we are taken here, collector voltage on for on transistor, that means it is in saturation. Then output voltage is saturation voltage, VCE sat. Similarly, the applied voltage between base and emitter VBE, this is saturation. So that means this is VBE saturation. Here it is VCE saturation. So this point VBE equal to VBE. VBE saturation. Similarly, VCE saturation, because this is on transistor. It is in saturation. This is it cutoff. Okay. First, let us take the pass on transistor. Okay, this is the Q2 is the on transistor. Then what are the different current we have taken? I2, I2 dash and IC2. These three currents belongs to the transistor Q2. I2, I2 dash, IC2. Okay, let us draw this circuit, same circuit from here to I2 dash, from here to here. Okay, circuit from D to, okay, R1, resistor R1. Next IB1, here it is divided into I3, IB1 from the circuit. This one I2 is divided into IB1, I3. Okay, I1, I3. And the down negative voltage minus VBB. Okay, from this circuit. Okay, and similarly I2. First we have to find out I2. I2 is starts from this is 2 and stops there VD. Okay, from this it is divided into I2 dash and IC. Okay, so it from this C to VD. Then I2 equal to I equal to V by R. Okay, apply KVL. So if we apply KVL, let us write VCC equal to I2 RC2 plus VD. I2 RC2 plus VD. From this equation, I2 equal to VCC minus this VD comes here minus VD by RC2. Yeah, this is the I2 value. I2 equal to VCC minus VD by RC2. Okay, so here this point A, IB1 means base of the transistor Q1. So we are assuming Q1 becomes off. For off transistor, base current is approximately equal to 0. Okay, base current is approximately equal to 0. We are assuming base current approximately 0. So then we know that I2 dash is divided into IB1 plus I3. Here base current of transistor Q1 is equal to 0. then I2 dash equal to I3. Okay, then I2 dash I3 equal to I2 dash, or I2 dash equal to I3. From this, I2 dash equal to, check, I2 dash starts here and flows through the circuit and ends here. So apply KVL. Then we will get VD minus of minus VVB, that means plus VVB by total resistance R1 plus R2. Okay, check it. I2 dash from starts from D and ends in minus VB. VD minus of minus VVB by R1 plus R2. So then I2 dash equal to VD plus VB by R1 plus R2. Okay. Next, we already completed I2 dash. Then IC2. We know that I2 is divided into, this I2 is divided into I2 dash plus IC2. Okay, then I2 equal to I2 dash plus IC2. From this, IC2 equal to I2 minus I2 dash. Okay, we already derived the equations for I2 and I2 dash. This is I2 and this is I2 dash. After calculating I2 and I2 dash, then we will get IC2 value. Okay, next, similarly, next part, to find IB2. Okay, base current, to find base current of on transistor. Okay, base current of transistor. Let us draw the path. Okay, where we get IB2 from transistor Q1. Okay, Q1 output is connected to the base of the transistor Q2. So we have to draw the circuit from Q1. VCC, RC1, next point C. I1 is divided into I1 dash plus IC1. This I1 dash again divided into I4 plus IB2. That is the base of the transistor Q2. Okay, I1 equal to IC1 plus I1 dash. Okay, IC1 plus I1 dash. So this is the Q1 is the off. Q1 becomes off. We are assuming Q1 becomes off. So for off transistor, collector current, output current is equal to 0, because base current IB equal to 0. If base current IB equal to 0, then IC equal to beta into IB. If IB is 0, then IC also 0. Okay, so IC1 equal to 0. Then I1 equal to I1 dash. Okay, so first let us write the I1. So I1 equal to I1 dash is completely I1. Again, I1 is divided into I4 plus IB2. I4 plus IB2. From this, we have to calculate IB2. From this, IB2 equal to I1 minus I4. I1 minus I4. Okay, from the circuit, I1 equal to, okay, I1 equal to, check, I1 flows starts from VCC2 and ends here VB. So VCC minus VB by RC1 plus R1. Okay, apply KVL. VCC I1 equal to I1 starts from VCC minus VB, at this point voltage VB by RC1 plus R1. Okay, similarly calculate I4. I4 starts from point B, VB2 minus VBB. Okay, so VB minus of minus VB, that means plus VB plus VBB by R2. Okay, if we calculate I1 and I4, then we can calculate IB2, because IB2 equal to I1 minus I4. Okay, so similarly IB2 minimum, we already know that IB2 minimum equal to IC2 by HFE minimum. So here we are calculating IB2 from the circuit, and from the given specification we have to calculate IB2 minimum. If this IB2 is greater than this IB2 minimum, the transistor Q2 is said to be on condition. Okay, from this circuit we can calculate IB2. From the given specifications we have to calculate IB2 minimum. If this IB2 is greater than given specifications IB2 minimum, then the transistor Q2 becomes on. Otherwise, the transistor Q1 is in off condition. Okay, these are the stable states, currents and voltage of bistable multivibrator. So we have to calculate I2, I2 dash, IC2 and IB2. Okay, next. Next we can see the design of bistable multivibrators, design specifications. Okay, now designing procedure of bistable multivibrator. First of all, check if the transistors Q1 and Q2 are NPN. Okay, na? We are assuming that this is NPN silicon transistors, and the two transistors Q1 and Q2 are NPN silicon transistors. For silicon transistor, VC saturation equal to 0.3 volts. Normal ideal case, for ideal case, VC saturation equal to 0, and VB saturation also 0 or ideal case. But here we are selecting silicon type. Silicon 1, VC saturation equal to 0.3 volts and VB saturation equal to 0.7 volts. Okay, this is the input voltage, this is output voltage. VBE input voltage, VCE output voltage. Okay, saturation means for on transistor, whether it may be Q1 or Q2. Second point, second designing step. These are all assumptions. Okay, to design any circuit, we have to assume all these assumptions. Next, the base current of the on transistor is taken as 1.2 times of 1.5 times of maximum value. Okay, so the on transistor, this is IB, this is the on transistor. If it is Q1, then IB1, we have to write IB1. If it is Q2, then we have to write IB2. IB2 equal to 1.5 into IB minimum. If it is IB1, here this is also IB1 minimum. If it is IB2, it is also IB2 minimum. Okay, 1.5 times of IB minimum value. So how can we calculate IB minimum? IB minimum equal to IC by HFE minimum. Already we discussed about this. IB minimum equal to IC by HFE minimum. Okay, this one is the second assumption. And third assumption, the current through the resistor R2, this one, the current through the resistor R2. R2 is connected to the on transistor. Let us assume Q2 is on. R2 is connected to the on transistor, and we are assuming this is as RI4. Okay, on transistor I4 equal to IC2 by 10. Okay, this is assumptions, all the standard assumptions. I4 equal to IC2 by R. If Q1 is on, here I am assuming that Q2 is on. If Q1 is on, then we have to select here I3 equal to IC1 by 10. Okay, see here if Q1 is on, then current is I3. Okay, here we are selecting just Q2 on, that's why I am writing this IC2 by 10. Okay. Next, current through the resistor R1 is ignored. Current through the resistor R1 is ignored. This current through the resistor R1 is ignored. Okay, current. Then I2 equal, we know that I2 equal to total current, I2 equal to IC2 plus I2 dash. You know, we are ignoring I2 dash. Okay, we are ignoring I2 dash. Then I2 equal to IC2. Okay, IC2. Already we discussed about this one. I2 equal to IC2. Okay, right. Next. Okay, these are the assumptions. Let us see once again. See the assumptions. First, saturation transistor output voltage 0.3 volts, input voltage 0.7 volts, and IB equal to 1.5 times of IB minimum value, and IB minimum equal to IC by HFE minimum, and I4 current through the resistor R2 is IC2 by 10, and I2 equal to IC2 plus I2 dash. If we ignore this current value, then I2 equal to IC2. Okay. Next, just designing procedure. A designing procedure means in any type of design, we have to calculate a resistor, inductor, and capacitor values. Okay, we have to find the equation for R and LC if they are present in this circuit. Bistable multivibrator, only resistors are present in the circuit. There is no R, L, and C. Only resistor values are present in the circuit. What are the resistor values? RC1, RC2, R1, R2. These four resistors are present in the circuit. Okay, Designing process means we have to calculate these four values. For any type of design, we have to find out RLC values, but we don't have LC values, we have only R values. Okay. First, to find RC2. RC2 means on transistor connected collector resistor. RC2. Okay, we are assuming Q1 on, Q2 on, Q1 off. Okay, we already know VC saturation 0.3, VB saturation 0.7. From VCC equal to, okay, VCC equal to, this can be divided into I2 RC2, I2 into KVL, I2 into RC2 plus VD. Okay, see this one is equal to I2 RC2 plus VD. From this equation, RC2 equal to VCC minus VD by I2. VCC minus VD by I2. VD is equal to VC saturation, because the Q2 we are assuming Q2 is on. On turns to VD equal to saturation. Okay. Next, to find R2. Okay. To find this R2, just write the current equation. We already know that I4 equal to VB plus VBB by R2. Okay, VB plus here, VB plus VB by R2. From this, R2 equal to VB plus VB by I4. VB plus VB by I4. VB equal to, VB means on transistor base emitter voltage, that is VB saturation plus VB by I4. And I4 equal to, from the designing specifications, I4 equal to IC2 by 10. This is the assumption. Okay. Next, to find R1. Okay, na? We have to calculate R1. We know that I1 dash is divided into IB2 plus I4. From the circuit, I1 dash is divided into I4 plus IB2. Okay. IB2 equal to 1.5 times of IB2 minimum. Okay. I4 equal to IC2 by 10. Then we can get, if we know these two values, then I1 dash, we know I1 dash. Otherwise, we have another formula. VCC minus VB by RC1 plus R1. Okay. From this, I1 here, I1 dash equal to I1. That means I1 dash starts from VCC and ends at point VB. So we can write VCC minus VB by RC1 plus R1. Okay, this starts from VCC and ends at point B. So VCC minus VB by total resistance RC1 plus R1. Okay, that is the equation I1. So if we calculate I1 dash, from this we can get I1 dash. We know the VCC value. We will get VB equal to VB saturation. RC1 also we can, RC1 equal to standard equation RC2. You know, already we know how to calculate RC2. We know all these values. If we calculate all these values, then we can find R1. Okay, in some circuits we can also as just R1. Okay, R1. Okay, na? This is the designing process, the steps. Okay, the next class we will discuss about, we will take some designing problem and we can calculate all the designing problems. Okay, just you can go through these designing steps, then we will calculate all the designing process steps in the next class. Okay, thank you.